Okay, example 22. We have 4 capacitors with a switch there and a battery. In part A, we're asked to find the equivalent capacitance of the group of C1 and C2 if the switch is open. So essentially you have 2 capacitors in series here and 2 capacitors in series here, and then these are parallel with one another. So let's find the total equivalent capacitance of this whole circuit. So when you have capacitors in series, it's kind of like adding capacitors or resistors in parallel. So it's 1 over C1 plus 1 over C2. This will give you an equivalent capacitance of 2 microfarads. And then this combination will give you a capacitance of 12 over 7 microfarads. So the equivalent capacitance, now adding these two combinations in parallel, would be the 2 microfarad capacitor plus the 12 over 7 microfarad capacitor, which gives you an equivalent capacitance of 26 over 7 microfarads. So let's go on to B, which is asking for what is the charge of the capacitors if the switch S was open. So if the switch S was open, and you thought of this as one capacitor, down here as one capacitor, then the plate here and the plate here would be sharing the charge that comes from this battery. But the capacitance of this one capacitor here and the one capacitor here, they would have the same voltage as the battery. So the voltage of 1, 2 would be the same as the voltage from 3 to 4, 3, 4 to combine, which would be the same as the EMF, which is equivalent to 12 volts. Then the charge from 1 to 2 would be equal to the capacitance of 1 and 2 times the voltage from 1 to 2, which would give you an answer of 24 microcoulombs of charge. And similarly, you will get an answer of 20.6 microcoulombs for the capacitors down below here. So maybe there's slightly more charge here than there is here. So we'll make this a negative over here and negative over here, or actually just 2 negatives there. And then we know that when the plates on each of these individual capacitors will have this equal and opposite charge. So this will become negative, and then that will draw a positive charge over here. And the same thing over here. This will become negative with 3 minus signs here, and then there'll be 3 plus signs over there. And so hopefully you remember that the charge in series will be the same. So the charge of Q1 and Q2, these two individual capacitors, will be the same as the total charge Q1, 2, which is 24 microcoulombs. And the charge from 3 and 4 will also be equal to 20.6, the total charge of 3, 4 together as one capacitor. Okay, now look at the situation where this switch is closed. So now what you have is 2 in parallel and another 2 in parallel, and these two parallel combinations in series with one another. So the total capacitance is going to change now. So let's find the total capacitance now. So we're going to add these two capacitors in parallel, so that's C1 plus C3, giving you 4 microfarads, and then do it for C2 and C4, yielding an answer of 6 microfarads. And now let's add these two combinations in series with one another. And this will give you an equivalent capacitance of 2.4 microfarads in this new configuration when the switch is closed. So let's find the charge as if this was one big capacitor. We'll call that Q, which is equal to the equivalent capacitance times the EMF of the battery. It gives you an answer of 28.8 microcoulombs. And this would be the charge that would be through capacitor 1, 3, and also the charge through capacitor 2, 4, which is equivalent to the total charge 28.8. Remember that capacitors in series with one another will have the same charge, which will be the same charge as the equivalent capacitance, or from the equivalent capacitor. Now what I'll do is I'll find the voltage drop across C1 or C3, or the voltage across 2 or 4. So the voltage across 1 or 3 is going to be 7.2 volts, and then the other voltage is 4.8 volts. It should make sense. If you add these two voltages, you get the total voltage of 12 volts here. So as you go across this resistor here, or capacitor, you can have a voltage drop of 7.2 volts, and over the last part here we have 4.8 volts. Then I can find the individual charges. Say charge 1 by taking the capacitance of 1 and multiplying by the voltage across 1, which would be the capacitance of number 1 was 1 microfarad, and then the voltage was over that one was 7.2 volts. So that gives you 7.2 microcoulombs. Charge for capacitor 2 will be 9.6 microcoulombs. And for number 3, you get 21.6 microcoulombs. And for number 4, 19.2 microcoulombs. And that's it for this problem.